Wan Halin Wang Hailin Virindashri Shazril Aiman. Are you all there here? I hear your voice.
Yes.
Yes, doctor.
Okay, good. So this is one of the group that I see the answers for the questions last week. Okay, good. Well done to all the groups. This group and other groups that have submitted their work. Okay, in this exercise, we can observe that 3 instructions from ISA has been used. Okay, also the first instruction is number 1. If you still remember, I just want to discuss back what we have learned before this, so that it's like that it's a continuation from the previous class to our class now. So we look at the basic instruction cycle, and then we can see that there are 6 steps here, and then the instructions that we use from ISE is load, store, and add, in order to tell the computer to add 2 numbers. So we want to add 2 numbers here, 3 and 2. So based on these instructions, which is the first one is to load, the second instruction is to add, and the third one is to store. Okay. The addition process, this addition process, we add 3 and 2, involves 3 cycles. Okay, this is the first cycles. We fetch, decode, and then execute. This is the first fetch, decode, execute. This is the second cycle. Yes?
Are you sharing the screen?
Yes, I'm sharing the screen. Can you see my screen?
Yes. No.
Yes.
Yes.
Oh, yeah. Okay. Now I can.
Is it okay?
Okay, Doctor. All fixed. Thank you. Sorry.
Okay. All right. So this is the second cycles, fetch, decode, and execute, and this is the third cycles, fetch, decode, and execute. So it involves 3 cycles of fetch, decode, and execute in totals. My question is, how fast our computer can process that cycles? Okay, we can see that there are 3 cycles here. So how fast that our computer can execute all those cycles that involve when we want to execute our program. In order to identify how fast our computer system can be, so today we will focus on this topic, computer performance. Okay, so this is our journey to complete this course, and this topic is our 4th topic this semester, which is to understand the key performance issues that relate to computer design. Okay, so this is there are some questions here. So what you can do during the lecture is you can open goformative.com. Okay. For example, you can go to goformative.com. Goformative.com. Can you all go to this browser? I mean go to goformative.com and enter the code. What is the code just now?
Formative.
UBWPOK. So you go there. QBWPOK. So you go Okay. Do you wish you click join? Can you open?
The name
Don't,
should we add
what is
the
Can, doctor.
our
Yes.
match number?
Yes,
Or is it the one?
doctor.
Okay.
Yes, doctor.
So I don't want you to do it right now. I don't want you to do. I
don't,
just want you to
doctor.
see only. Okay. At this time, I just want you to see what are the questions here. Don't do it yet. But when I'm giving you the lecture, for example, I'm giving the lecture about topic cash. So you can, oh, this is the cash. There is a question about cash just now. So you just refer back to this question and give the answers. Do you understand me?
Doctor,
Yes.
at the name section, should we add our matrix numbers or just our name?
Yes, please.
At the name section, should we put our matrix number or just our name?
You can put both. Okay. Your metric number and then space and then your name. It's better like that. Okay. So you just browse the questions. Don't do it yet. And then there is some question about multi-core. Okay, we will look when we have arrived to that topic, then you try to give the answers here. Is it okay? So,
Okay.
all right. So we will discuss again about these questions. So we now continue to our class. So I hope all of you have go to go formative and then put this code
Tengok tengah dengar
QBW.
kelas at the same time ni. Hebat tak hebat?
So now I will continue. All right. Okay. Is many key performance. Is clock speed only the key for performance of the computer system? Okay, let's consider this situation at Ahmad's store. So I just read that situation. So you also can read. At Ahmad's computer store, you overhear a customer asking Ahmad, what is the fastest computer in the store that he can buy? And Ahmad replies, you are looking at our Macintosh. The fastest Mac runs at clock speed of 2.0 gigahertz. If you really want the fastest machine, you should buy our PC with 2.4 gigahertz. Is Ahmad correct? Yes or no? Who?
Yes.
Yes, yes.
Uh,
Yes, yes.
Ada
yes or
pakai.
no?
Yes.
Yes or no?
No. Yes or yes?
Yes.
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 Yes, yes, yes.
Maybe I call one name here. Yang mana yang kena Yes. Tak, yang last lah. Tengok siapa yang last. Oh, dah, okay. I give to Syafia. Are you here, Syafia? Alright. So yes or no?
Yes.
Just click there. Alright, thank you, Safia. Okay, what does it mean? Okay, what does it mean? This is actually a drawing by my daughter using this tablet.
Uh-huh.
She's quite good.
Is it the only
This is
key?
cute.
Cute, right?
No, no.
Not cute?
Oh. No.
Budak
The only key.
13 tahun
No. Ada
13
Paxton.
tahun.
Horrible drawing.
Adorable.
Ayo. Dia main-main je ni. Okay, is it the only key?
No, doctor.
No.
No.
So this is the answers. Okay, when you go shopping to buy a computer, what you should consider. So yes, yes or no. It is also correct that you said that clock speed is one of the key performance that you should look, right? But Plus, we also want to look what are other key performance that we need to consider if you want to buy a computer. Okay, let me check here. Okay, so there are 5 keys of performance or factors that affect the computer's performance in addition to clock speed. So the first one here, the clock speed. The clock speed means how many instructions can be executed per second by the CPU. There is this on that situation just now. And then the second one, we look at how many gigabyte of data in RAM. So we look at main memory. The third one is cache. How many megabytes of data in cache? The fourth one is about the transfer rate. How the transfer rate of the secondary device. And then what else? Number 5 is what you cannot see, right? Length of words. Okay, length of words. If I have 8 gigabyte of RAM, should I buy a computer with 32 bits or should I buy 64 bits? So the length of words, yeah,
64 bit,
64,
doctor.
64.
yeah, correct, 64 bit. Alright, good. The last one, how many cores? Does your program will run faster than with a single core if you buy a multi-core CPU? So these are the factors that we need to see in addition to clock speed. Can you find the key performance here from this uh, specification that I took from this website? So what you can see here?
Specification, process, CPU, RAM, and
CPU, RAM, SSD.
storage.
All right, good. So you have CPU here with 2.6 gigahertz, and then you can find cache, 12 megabyte cache, and then you can find RAM here, DDR4, 16 gigabyte, and then you can find the storage, 512 gigabyte SSD. So you can find also many technical things, DDR4, PC4. You can, yeah, the speed. You can, if you want to know more, you just search this technical terms here. Okay, because the technology is changing almost every year, so the technical things here might change, but the basic concept, for example, the fundamental concept of CPU, RAM, and storage, we will cover in our course. Okay. Okay. First, we look at the first key performance, which is clock speed. Okay. So, do you like to buy this computer?
Yes.
Yes, I would like.
I would like to hear.
Yes.
I would
Okay.
want that.
Any of you have this model of computer?
No,
No.
too expensive.
Nope.
Me.
What do you use?
I want a
Kentang
PC.
one. I have the kentang one.
I want an RTX 3090.
Okay. So I just search from the internet this ASUS laptop. So this is the custom we can customize the laptop, and then this is what I select. This laptop has 2.6 gigahertz. So this computer has a processor that runs at 2.6 gigahertz. So this value, this gigahertz, 2.6 gigahertz, is related to the clock. Okay, this is not the clock on the wall. Okay, this is the clock in the motherboard that keep the computer system synchronized. So usually this is like quartz crystal is actually located in your motherboard. So the computer need this clock in order to synchronize all the components inside the computer. This is very important part that you need to know. Okay, so this is the very small component here. So the clock, let me change. I really want to draw. Let me. Okay, so this is the clock. Okay, so the clock emits signals, and one clock cycle has one rising edge and one falling ground. So this the quartz crystal is this. Okay, so this clock will emit signals. This is the signal. When you look into the signal is actually has one rising edge, and then it will followed by another one, which is falling ground. We call it falling. This is rising, and then this one we call it as falling. Okay. So when we talk about a clock cycle, I hope you please understand this. Clock cycles means it contains one rising and one falling. Okay, this we call it as clock cycle. Okay, do you get this one? What is clock cycle? All of you get it?
Yes.
Yes.
Okay.
Yes, doctor.
So how to measure how many clock cycles in 1 second? So to measure how many this clock cycle, 1, 2, 3, the measurement that they use is based on frequency, or we call it as cycles per second. Okay, in 1 second, how many cycles here can be run by the computer? Okay, so the unit here is hertz. So that's why we see just now the value is gigahertz, because this is the unit hertz, which means that the frequency of cycles in 1 second. So can you imagine that? How many actually cycles emits from the clock within 1 second? How many? 2.6.
2.6 billion maybe.
Too many.
Yeah, can you imagine that? Your computer do that. So be nice to your computer, okay? 2.6 billions of clock cycles happen in only 1 second. Okay, this also the reference is quite technical here, but if you want to see these figures, I took from this reference, Science Direct. So this is the time between the rise and the fall, and this we call it as clock cycle. And one of your friends also asked me about the textbooks. Another textbooks that you can refer, which is quite good, but a lot of technical details. You just read the related one, which is from William Stallings. This book is Computer Organization and Architecture, Designing for Performance. Okay, you can find this book. Okay. So the more clock cycles at one time, it means that the more work can be done by our computer. Okay, so like we said just now, the spec shows that the computer is able to run at 2.6 gigahertz, which means that 2.6 billion cycles per second. So if you still remember our video here, the man with the red t-shirt, you still remember this video?
Yes.
Yes.
When the man use his finger, right? Can you do
Yes.
that?
Yeah, petik jari.
Exercise your fingers. I want to see your fingers. Can you please do that? 2.6 billion in 1 second. Can you do that? using your fingers. Is it possible? Cannot, right?
Impossible.
Impossible.
So fast. Possible. It's very, very fast inside the computer. So when you look back into the example we learned in our first class before this, um, I asked the question, if you still remember, how many clock cycles are needed for the 3 fetch, decode, execute? Not for 3, for 1. Sorry for that. So they need about 3 clock cycles. Do you still remember? Do you remember?
Yes.
Yes.
Yes, I
So
still
it means
remember.
that, that's good. So it means that at 1 clock cycles, you will do fetch, and then another 1 clock cycle, you will decode, and then another clock cycles, you will execute. So for one instructions, it needs have 1, 2, and 3 clock cycles in order to complete one instructions. Can you get that? I hope so. Is it okay?
Can you explain again, Doctor?
Yes.
Okay. Okay. So we have looked so far to the clock speed, how fast our computer can run our instructions. Okay. If your computer able to do 2.6 billion per second, so you can imagine how many instructions can be run within 1 second. Okay. But we also need to look at how big the size of work or program that can be loaded to our main memory. And now we look at the second key performance, which is main memory. So this is a picture of memory. If you look here, this is the picture. This is the main memory for this spec. Okay, so the spec shows the size is 16 gigabytes. This means that it has the capacity for 16 billion characters, which means that you still remember 1 byte is 1 byte 1 bit, is it correct?
1 by 8 bit.
What is the correct one?
1 by 8 bit.
1 byte equals to 8 bit.
8-bit.
Yes.
1 byte,
Okay.
8-bit.
In 1 byte it contains 8 bit. Okay, you can change that after this. Okay. So if the spec said 16 gigabytes, it means that it can hold the capacity up to 16 billion characters. Okay, this show the capacity of our memory. So you can look further into this computer from these websites where you can customize a computer. Okay, my questions. If you have 200 ringgit or 300 ringgit to improve the performance of your computer, what would you choose? You want to add more RAM or you want to add more secondary storage? Anyone?
More RAM.
RAM.
More RAM.
More RAM.
Why you want to add more RAM?
I choose both, Doctor.
Not enough
Kalau
money.
if the RAM is already 16 gigabyte, then maybe secondary storage.
Okay, you already have high RAM, size of RAM. Okay. How about others?
Dual channel RAM.
RAM.
Need both.
Both. Oh, you have, but you only have one choice. It depends, right?
RAM.
On your
Yeah.
okay. So bigger
Depends.
RAMs means more what here? Can be loaded to the main memory. So we will cut the time to load the memory from the secondary storage. So bigger RAMs means more what?
More instruction.
Instructions.
Okay, yes. More instructions. Okay, bigger RAM means more instructions can be loaded to the memory. So if we cut the time to load the memory from the secondary storage. Okay, so if you, any of you have tried ED puzzle before class?
Yes.
Yeah. If you have no time to do that, you can do that after class today. It's very good to see the connection between memory, CPU, and secondary storage. Secondary storage. If you watch the video, it says that the CPU is related to IPO. If you still remember IPO,
Input, processing, process output.
Output, yes, correct. So the central here is process. So the CPU is the fastest component in our computer. So it will done the execution. So it needs to interact with the next fastest in the computer system, which is memory. So that's why if we have bigger RAM, it's better because we can load bigger size of instructions, more instructions in our memory. Can you get that? Because the CPU only interact with the main memory will get it from the secondary storage. Okay, so we just proceed first. Okay, do you know about DDR4? What do you know about DDR4?
Type of RAM.
Ada yang order barang ke? It's okay. 16 gigabyte DDR4. DDR4 means double data rate. Okay, still remember our clock cycle just now? This is our clock cycle.
Yes.
So this is single data rate. Okay, this is non-DDR, only single. How about double? What happened in the double data rate? It means that double data rate, it can sense double the amount of data in each clock signal. What does it mean is that in one clock signal, at the moment it's single only one. But now for the double data rate, it can sense double. Okay. So this is data, X is data. So this is what happened. Your computer now that support DDR and now type 4, it can send double data rate. Okay. You can, in the end of the slides, there is, bottom of the slides, there is a YouTube. You can gain more information about RAM. The technical parts of the RAM, you can learn more from the YouTube. I share here actually. You can find in the slides. Okay. All right. So this is for santai. Do you know santai? Okay. Penat ni kan belajar, kita break sekejap. I mean bukan break 10 minutes tu, just to show something non-academic. So how about us? Where do we store our memory? Where do you store your memory?
Hard disk.
Brain.
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 Yes.
Brain.
You remember all the things in your life?
No.
No.
Not specifically.
Of course not.
Not really.
Yes.
So yeah, like when you use your computer, you please do backup right? You do backup, especially for your important assignments, right?
Yes.
Yeah.
Alright.
Please do that. Especially if you have big project, please do backup. Especially the simple way is to email yourself the file using your Gmail. This is the simplest way for you to do backup. Like me, I don't always remember all things. That's why I make a blog here. This is my blog. It's not active anymore. I just make a blog to store my memory when I did my PhD in Auckland, New Zealand. Okay, so this is how I store my memory. This is my, okay, can you see this person here?
Yes.
Yeah, this is my supervisor, my PhD supervisor. I just want just to share my uh, life as PhD students. Okay, so this is from Brazil. This is for China. It's very good person, Wei Yu. So I did my PhD here in chemical and materials processing. I did data mining in aluminum processing. So I hope all of you also can further your study. So anyone of you want to further study, master PhD?
Yes.
Oh, obviously,
Yes.
yeah,
Kalau ada peluang.
yeah, take
Maybe
yeah, you can take opportunities to go overseas to further your studies. But also as a students here, I don't know, but your seniors, we ask them to make a blog, okay, to record their activities, blog using WordPress. Before this, we call it CV using WordPress, where you update all the activities in UKM, especially in SIG. If you represent your club or the faculty in any competition, it's very good for you to update in a blog, for examples, so that when you have like a working CV, so if you have to fill your CV, all the information is there. Okay, I hope all of you can go for that, to have a blog during your time here. Okay, I just proceed. Can we proceed? Okay,
Yes.
but why? We know that main memory is fast here. But why we still need secondary storage, although we know that RAM is faster than secondary storage? Why?
RAM is volatile, so it needs electricity. If not, it will lose memory. While secondary storage, it just keep the storage without it still keeps the storage even though without electricity.
Good.
Yeah, something like that.
Yeah, correct. Correct answer. All agree with that?
Agree.
Yes.
Agree.
yes, agree.
Yes.
Agree.
I also agree with the answers. Okay, because RAM is volatile. Volatile mean memory that is lost when power is off. Okay, so when the power is off, the memory loss is lost. Therefore, our computer needs secondary storage. Okay, which is non-volatile. So our secondary storage is non-volatile. Okay, to store our data when the power is switched off. So that's why we still need this secondary storage. But now our secondary storage is quite good, right? We have SSD. Do you use SSD now?
Yes.
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 Yes,
I
doctor.
think now we are going to use most of the computer
SD
going to,
lah.
right? So this is the overall memory that we have in our computer. You have know about registers, and then the next fastest is cache, followed by main memory, and the last one, which is the slowest one in our computer, is the secondary storage. Okay, and one way to improve the memory is in our computer is to have memory inside where?
CPU.
CPU.
Inside CPU.
Yes, good. Inside the CPU. Because before this, we learned that we have CPU, we has memory, and then keep flash from the memory, and then the memory actually get the programs from the secondary storage, where you double click the programs. What happened is that the program inside the secondary storage is loaded into your main memory, and then there is a mechanism here where we call it as scheduling. We will learn more when we look topics about operating system OS. Okay, so this is just the brief explanation about how it works between this component. So if part of this instruction inside the CPU, it will be much faster. Okay, so this memory is called
Cache.
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 Right. Is the like money, right? Cache. So this is the CPU. So inside the CPU is cache here. So what else inside the CPU? The important thing.
Registers.
Control unit. Yes, we also have registers. And then
ALU,
ALU.
CPU.
ALU.
we have so one way to improve is to have cache inside our CPU. So you can find a lot of information about cache from YouTube videos. This is I print screen from a video. Okay, we can see that I like this video because it has this animal here. It represents the cache because the cache is much quicker to access the RAM. Okay, so that's why it's often used instructions will be stored there. Okay. Next. Cache is used to store program instructions that are frequently or not.
Frequently.
This one, right?
Frequently.
Frequently re-reference. So we will put here. The cache is used to store program instructions that are frequently re-referenced by software during operations. And it is not big as our RAM. It is measured in megabyte. Okay, I think this is the last one before we have a break. Second last. Okay, we want to finish the cache first. Okay. Okay, how to fill this one? The cache contains a copy of portions of main memory. Okay, just read that. All of you can read that. I also read. Try to see how you can draw here. In the middle. What is the middle there? Okay. The cache contains portions of main memory. Alright. The processor attempts to read a word. A check is made to determine if the word is in the cache. If so, the word is delivered to the processor. If not, a block of main memory consisting of some fixed number of words is read into the cache, and then the word is delivered to the processor. Okay, first thing first. What is here? What do you think here?
Cache.
Tak nampak doktor.
Oh, saya tak nampak. Okay, what is here?
Oh, that one.
Yeah.
Cache. CPU.
Try again. What is here?
RAM.
What is here?
Main memory? Oh, no. Salah.
No, hard drive.
Hard drive.
Okay. Anyone want to control? Anyone want to write or what you want me to write? Let me. What is this? Okay. What is the middle here? What do you think?
CPU.
CPU?
No, if CPU is on the middle, then what's on the left?
CPU here?
Catch.
CPU here?
Catch kan?
Yeah, CPU.
Catch.
Okay. CPU? Agree?
Yes.
Yes.
Yeah.
Okay. In the middle?
RAM.
Cash.
RAM.
Cash.
Cache.
Cash.
Cache. Memory.
Cash.
Cache or RAM? Cache or RAM?
Cash.
Cache.
Huh? Cache or RAM?
Catch.
Cash.
Catch.
Okay, remember, cache is
Cache inside CPU, right?
nearest one with the CPU. So it should be
Catch.
cache, right?
Okay.
So because still remember the cache is inside the CPU, right? Cache, CPU, and the main memory is outside there. It is in the when you find the CPU, it is inside that. The RAM is another component outside. So the cache here and this one should probably be the RAM. Okay. Which one is fast? This one or this one?
Cash.
Left.
Fast. So this should be fast, right?
Cache is
This one, the between the RAM and the no, sorry. The cache and the RAM is much slower. Okay. Okay, last thing. Between the CPU and cache, what is being transferred here?
Word.
data and bits.
So this is the word transfer. If the word is in the cache, the word is delivered to the processor. So the CPU will check. Let's say they want to find an instruction need to be executed. The CPU will check first in the cache. Is it inside the cache? If yes, the cache will transfer the word or the instructions into the CPU. If not, it will go to the RAM to find that instructions, but it will not only take that one instruction, but it will take a block of instruction. A block. So this block of instruction will be transferred into the cache. Block transfer. Because the CPU might want to use these instructions, but later, you still remember PC counter? It will usually want another instructions, the next instruction inside that program. So that's why you will have block transfer into the cache, and then this block will inside the cache, and the CPU will check is there any instruction needed by the CPU inside the cache. Maybe the next instruction here is needed by the CPU, and these things, or we call it as word, will be transferred into the CPU. If not, then we find another block to be transferred. Okay. Is it clear how the cash works here?
Okay.
Any questions about cash before we stop for a break? Okay ke ni?
Okay.
So far,
Setakat ni
okay.
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 Okay, that's good.
Okay.
Okay, you want to have a break now?
Yes.
10 minutes?
Boleh juga doktor.
Alright, so I share again the screen. Remember to do this if you already have the idea. For example, here clock speed is measured using. Only do questions that we already have go through. So okay. So I leave it just now. We break 10 minutes. We start again at 5 minutes. Okay? Yes.
Doktor boleh share QR code tak?
Boleh?
Thank you.
Alright. Saya tak ada kat PC sekejap tau. Saya datang balik. If you have any question, you can just message in the Microsoft Teams. Okay? Okay, can we continue our class?
Sure, Doctor.
Okay.
Yes, Doctor.
Alright. Dah minum kopi dah? Tak minum pun? Okay, we continue. Okay. So just now, we look about how cash works. Just briefly said again that if the CPU needs some instruction to execute, it will look first in the cache. We call it as word, okay? If the word is in the cache, it will transfer to the processor, the CPU. If the word is not in the cache, what happens is that the blocks of main memory consisting of some fixed number of words, okay, a number of instructions or words, it will transfer into cache, and then the selected word from that block will be transferred into CPU. Okay, so that is how CPU works in the cache. Okay, where is the location of the cache? Is in the CPU, just I said before, and it can be many level. Okay, as we can see here, the level of the CPU, it can be level 1, it can be level 1, it can be level 2, it can be level 3. Level 1, usually for each core, level 2 also for each core, and level 3 usually shared among all cores. So this is all the levels. Okay. What do you think will be the first block here?
Level 1.
Level 1.
Why level 1?
Smallest and nearest.
Okay. So this is level 1. Has fastest connection with the CPU. And then also smallest. The second one is level?
Level 2.
Level
Yeah.
2.
Level 2. In the middle, and the last one definitely level
3.
3. So this is how the designer of the computer try to improve the performance of the computer. So they said that we put the memory near to the CPU. That's why they design cache. Okay. So this is in our modern computer, not in the von Neumann architecture. Cache is not in the von Neumann architecture, but in our modern architecture and organization, they put cache to improve the performance of the computer, because the idea is that the CPU can execute the data better if the data that they need is near to them, and they can reach the data, reach the instruction as fast as they can. Okay, so because the CPU is very fast, still remember for this spec 2.6 gigahertz. So if you only has the fastest CPU but others component is not support you, so the overall performance is still not very okay. So that's why they also need other component like cache and also the local bus to support the performance. Okay, that is the third key performance. The fourth key performance that we look now is transfer rate. Okay, that's what I said before. We not only look at the memory that we use, but we also want to look at the transfer rate. Okay, when looking at the storage device, we are looking for the storage speed, we call it transfer rate. So it is measured. What do you think? If it involves data, usually we measure BPS. B stand for bit. Okay, bit per second. A little bit about history. Before this, we use magnetic storage hard drive. The magnetic storage is still available for your information. I have friends that work in a company that almost every week, I think, in the end of the week, they transfer data from the server into tape, magnetic tape. Okay, the data in Singapore, the tape in Singapore, so they transfer there as a backup. Because for the backup, they need the cheap solution. So they for backup they use magnetic tape. Magnetic tape to do backup. It's still available now, but only for backup. Okay, and of course it takes times to do the backup. Sometimes few hours if the data is a lot, but it's still available magnetic tape to do backup. The magnetic tape is measured revolutions per minute, but now we are going to solid state drive because this technology is based on the flash drive, like USB drive. Okay, so the both SSD and USB drive now is based on the NAND base. This is the technology. Okay, if you this is the USB NAND flash. This is the type of technology now they use in order to improve the performance of the transfer rate. That's why if you can compare, if your computer use hard drive, which is still hard disk, which is still mechanical, and you compare with SSD, you can see the difference to load the information. Because still remember, when you want to execute the data, this is your RAM. Every time you double click any icon that you want to execute, or you, for example, games, they need to copy first from the secondary to RAM. So if your SSD is your hard disk, secondary storage is SSD, so it will be much faster than the old technology. Okay, that is for the transfer rate. And then the fifth one, the length of word. Okay, so word is actually we can call it actually the instructions. The length can be different. It can be from 8, 16, 24, 32, or 64 bits. And now we can find that most modern computer, we use 34-bit, but I think more and more computer now are going to 64 bits. But you still can find 32 bits for the old computer. Okay, so it means that if you have 64 bits, of course, it will be more later at one time, so the faster of the processor. And the length of word is measured in bits. Okay, so this is my question just now. If you upgrade to 8 gigabyte of RAM, you just wasted a whole lot of money because OS will not address beyond that memory address. That's why we buy. So what do you think this situation is for? 32-bit or 64-bit?
32 bit.
Yeah,
32.
bits, right? So that's why we buy 60. That's why we buy 60 bit because we can have a larger memory bank. Okay, so we can store more data in our RAM. So if you have more RAM, if you have a very big programs, it will cut back time between fetching the secondary disk. Okay, this is 64-bit. What does it mean? We will learn more about this topic in virtual memory. If you heard about virtual memory?
Yes.
I've heard of the term.
Yeah, you have heard
yes.
that, right? So it means that this is your CPU, this is your RAM, this is your secondary storage. If your program is so big, your RAM is small, what happens is that the computer takes some part of the secondary storage as RAM. Okay, so this we call it as virtual memory. And when this happens, your computer becomes so slow. Okay, that's why if your RAM is small, you can see that, I can still run this program, but suddenly your computer becomes so slow because they actually use the secondary storage as part of the RAM. We will learn more about virtual memory in topic memory management. Okay, I just give some idea here about memory management. Okay, I proceed with the last one, Matiko. Okay, so far so good. You still with me there?
Yes, doctor.
Yes,
Okay, can I
Yes,
proceed?
doctor.
Okay.
Yes.
Okay. How you wash your clothes? You have washing machine at your home now?
Washing machine.
You have dryer?
Yeah.
No.
No, I don't have dryer.
No. Natural dryer.
So you manually dry your clothes outside the house, right?
Using the
My dryer
sun.
is the sun.
Sunlight. Okay. So yeah, actually I want to use this washing machine and dryer as examples to explain to you about the advanced design of computer, which is multi-core. Okay. But before I go to multi-core, you need to know about thread. Okay. To understand multi-core, you need to know about thread. Okay. So what is thread? Thread is let me check. Is there information here? You know, I just put here. So what is thread? You know thread? In Malay we call benang.
Yes.
Yes.
Benang, eh?
Berbenang.
Benang, eh? Thread. So we have program where you execute a program execute the program, it will call process. Okay, process is program in execution. Okay, every time you execute any program, it will become a process. We call it as process in a computer. Okay, you can find it in your task manager. They will call all the programs that you have opened as process. So in the process, to support multi-core, actually your computer also need to support thread. Thread means that the process you can divide more into a number of threads. So thread is a unit of an execution unit of process. Okay. Kira macam anak lah, small part. We divide the process into an execution unit of, we divide the process, and this one we call as thread. Okay. Our modern computer now, they support to do this if they need to use multi-core. Okay, so I would like to refer to these examples. Let's say you have one load of dirty clothes. You have a dirty clothes here. Okay. And then you have a washing machine, and then you have a dryer, or you hang, but in this case you have a dryer. Okay, so what happened is that you put in the washing machine, finish, you put in the dryer. So this we call it as a pipeline. Satu aliran, pipeline. Okay. So it's a sequence of process here, washing machine and then dryer. So I proceed. Okay. Before we go to the meaning of multi-threading. Okay. Let's say you have two loads. Okay. Maybe you don't wash your clothes for 2 weeks. So you have two baskets now. First basket and two baskets. Okay. For example, first you have one big basket because for 2 weeks your clothes become so bigger, so your basket is not enough to put all your clothes, so you put one big basket, and then what happened is that your computer, your washing machine is not able to wash all the clothes, so you have to divide. Okay, so this load, you can imagine this one as one thread, this one as one thread, and this one as your process. Okay, can you get that? You have a lot. Yes or no? Okay, maybe I explain until finish, and then you can see whether you understand or not. Okay, so I put the first load in the washing machine and go to the dryer. Okay. So I put this thread into my washing machine, and then after finish, I go to the dryer. Okay. So my washing machine now is free or not? It's free, right? Because
Free.
yes, because the first load is here. So we can put the second load into the washing machine. So after this finish, number one finish, you can fold if you kalau rajin terus lipat, and then you can put number two inside the dryer. So what you can see from these examples is that we can run both loads or thread at the same time. This is the concept of multi-threading. So multi-threading is the ability of a CPU, central processing unit, or a single core in a multi-core processor to execute multiple processes or threads concurrently. Okay, so it means that when we say that your computer can support multi-threading, it means that they divide the process into a small number of units. We call it as threads. And then what happens is that in your computer, is based on the resources in your computer. For example, fetch, decode, execute. When one thread is fetched, it will go to decode and it will go to execute. But when at this stage, another thread can go to be fetched. Okay, it means that at the same time, so this is like a pipeline. So at the same time, two threads is actually inside your CPU. So this we call it as multi-threading. Multi-threading means more than one processes can be executed at the same time, but by different resources. For example, here, at the same time, one your clothes inside the washing machine, and another load into the dryers at the same time. Okay, so at last, maybe after 2 hours, all the loads is finished. You don't have one load until dryers finish to put in the washing machine, because the washing machine now is free, so you can put another task inside the CPU. So you get the concept of multi-threading here. Any questions about this? Okay ke ni?
Okay.
So far,
InsyaAllah.
Faham.
Multi-threading is like process that can like we can do multiple process at the same time. Is it like that?
The CPU, yes. We call concurrently. Okay. So at the same time, the unit of process, which is we call thread, can be processed by the CPU, but by different components. Okay. For example, the component for fetching, they can fetch, but another component execute.
Okay.
Fetch is by CU, right? Execute is by ALU. So we can see at the same time they are processing, but not at the same level lah.
Oh, in order to make the processing accurate at the same.
Yes, sorry. Is that a question?
Mute dong, mute.
Okay. Any more question?
I had one.
Okay.
So does the multi-threading is like a virtual core, CPU core?
Okay. Multi-threading is related to process.
Oh.
Okay. Okay. Multi-threaded is related to process. It's a unit of execution. Maybe I can proceed to explain about multi-core. All right. Okay. Okay, this is an example that I show just now. Okay. For example, when this is the thread here, unit of execution unit of process or we call it as thread, is executed by the ALU, for example. Another thread can be fetched by the CU. So at the same time. So this is inside one core. Okay. So what is multi-core? That's inside one core. Okay. You get me there? How about
Yes.
multi-core? Multi-core is about you not only have one washing machine, but you have two washing machine. You not only have one dryer, but you have two. Dryer first, and then dryer number two. Dryer. Okay, that is the meaning of multi-core. In the computer, you not only have one ALU, but you have two ALU. This is the first ALU, and then this is the second ALU. First one, this is the first core, and then this will be the second core. So can you find the difference here? So they might share the cache. Okay, before this we have thread. So thread go to here and thread go to there. So in this case, my question is, can we execute more process here in the multi-core? Yes or no?
Yes.
Yes.
So because we have multi-core, your friends can also wash your clothes in your house because you have two washing machines and you have two dryers. So you can take more loads here, more loads or more tasks. Okay. The same like here, it can try go to here and then they are also try go to there. So this is the concept that you can see. Why multi-threading is important? Because if you cannot separate the task, the only one here, the big one task is only here. You not divide the task process. It's only here. If we do multi-threading, it means that this process you can divide into a small unit, so that your resources will be effectively used. First core and the second one core. Okay. So how multi-core processors can improve the performance of a computer? Because more cores, CPUs means better, quicker performance. Different CPUs can work on different programs at the same time. So this is the meaning of multi-core. You have more resources in your computer, more ALUs, more CUs to process your program, your instructions. Okay. So actually, we are almost the end of our lecture. Before we have some quiz, okay. So we do some summarize here. When you go shopping to buy a computer, what you should consider? The first one. What is the first one?
Speed.
Yes.
Not speed.
The clock
Clock
speed.
speed.
Clock speed.
Oh,
Ini nama lah. Okay. Number two, no Shafika. What is number two? Shafika ada. Tapi jawapan dah ada tak apalah. So number 2 is RAM, right? Number 3 is cash.
Cash.
Yeah. Number 4 is
Transfer rate.
Transfer rate.
Transfer rate.
number fifth one is the length
Length
of
of word.
Length of word.
Length of word.
and the last one.
Number
Number
of
of
Number
course.
of
course.
course.
Okay, good. So this is the 6 key components. Okay. As usual, if you do have time in your groups, I really like you to go to here, CPU Bish here. Benchmark, sorry, Bish pula. CPU benchmarks here. You can see that. Any of you use AMD?
Yes, yes.
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 From the this is the top one lah, Ryzen. Is when you compare to Intel Core, it said that this is the mark is higher than the CPU mark is higher than the Intel Core. So I would like to see the discussion inside your groups. Okay, which processor that your group will choose and why? Just take 5 to 10 minutes only to discuss with your groups. Okay, during some any times in your WhatsApps or so on. Okay, what do you think? Okay, both CPUs use the same instruction sets. Yeah, try to get the answers. So lastly, explain how multi-core processor can improve the performance of a computer. Try to find more information about multi-core processors. Okay, so any questions about this before we go to Kahoot?
For now, no.
No,
No, doctor.
Saya actually quite happy, very happy when you do the task with your groups. I hope that you can retain any groups for discussion. As we will have, like I said before, we will have quiz for tutorial 1 and tutorial 2. But we will let you know. Just get ready. Okay, do your best for your tutorial 1 and 2. You need to submit your tutorial 1 and 2 to be eligible so that you can do the quiz. If you not submit tutorial 1 and 2, you are not allowed to take the quiz for the tutorial. Okay, so the time is maybe week 5. Now is week 3. Okay, week 5 or 4. It will let you know 1 week before the quiz. Same about the lab. There will be some lab evaluation. So as long as you do the tutorials and as long as you do the labs and you do understand what you are doing, inshallah you can score the quiz. Okay. So like usual, I really want you to do this form because I want to track your thinking about your learning. Okay, can you do that for me?
Yes.
Yes.
You just isi dengan hati I mean jangan tick je based on your really on yourself. Okay. Now I would like to go to Kahoot. Can we do Kahoot now?
Yes.
Yes.
Okay. At the moment, okay, have you done this? Okay, I will do Kahoot, share the Kahoot, and then so this is the quiz for the last for seniors. We do quiz using Kahoot. Um,
Sorry doktor. Untuk form tadi tu, I think the form is originally made for year 2 students and above because for computer science course, it has already been separated into specialization.
or you can choose any. It's okay. And any of the, yeah, we need to edit the form. Actually, we should only put computer science program. I don't know here whether all of you can enter. Is it up to 50? Any of you play Kahoot games before this in UKM?
Computer
Yes.
programming.
Yes.
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 Is it possible of you
Yes.
to enter the games?
Yes.
Okay, we try
Yes.
first, okay? We try first.
Aku rasa mic aku pro.
Doctor, my Kahoot still loading. I couldn't enter the pin.
Can we start now?
Yes.
Yes.
Some of you have computer problems with your internet. Have any of you have problems with internet? If you can have problems, you can DM me, okay? WhatsApp personal me or email me. Let us know. Okay, so I think we just start. We have 8 questions. So at the same time, I hope all of you can finish this work for the one that has tried to answer informative here. Okay, that you are with me during the class. Okay, I think I just start 232. Okay, just start now.
Madam.
Yes.
Okay.
Can I start?
Yes.
Okay, what happened here? Who choose this one? Ada yang nak mengaku tak? Okay, definitely the answer is cash because the keyword here is frequently re-reference. So any question about this one? You know why it's wrong, right? Okay, boleh proceed
Yes.
Yes.
Okay, start proceed. Okay, well done. Question. Okay, GD, Miza, Bulya, and Is.
Doktor. Okay.
What happened here? When the processor attempts to read a word of memory, a check is made to determine if the word is in cache. If so, okay. So I think you should refer back here in our lecture 4.
Doctor, the question was lagging just now.
Oh.
Yes, doctor. Yeah.
You cannot see the answers.
Yes, doctor.
We cannot see the question at first.
Or you just pick the answer.
Soalan dia dua lambat.
Randomly
Jawapan
just pick.
Yeah, it's necessary.
Okay, itu problem. Tapi faham lah kan? You understand kan, right?
Faham. Lepas tu masa dah berlalu.
Okay, good. So I hope this because of technical problems, right? Okay, so the answer is the red one. The word is delivered to the processor. Okay. Okay. Okay, good question, Mirza, Buya, Siddiq, and GD. Next. Cache is located on CPU chip. false or true?
Doctor, why do you flip through walls?
Is it the same technical problems?
No, it's not
blue one is
technical
true.
problem, it's
The
design
colour.
problem, lah, teacher.
We thought always the blue one is true.
Blue.
And the red one is
Yeah.
false. So we just take the blue one.
Yes, that's true.
Oh, you get wrong with the color.
No, doctor, because we cannot, I assume that all of us cannot see there are words on the box, only colors. So,
Usually the first one is true.
Oh, okay.
You need to read first
So
lah.
all of you agree with the answer, right? True?
This is true.
yes, it's true.
Agree.
That's
This
true.
is the technical problem, right? Okay. Let me see the next question. Okay, Vision GD. Gonna get name here. See. Continue. 4 more questions. More letter at one time, the faster the processor. This is measured in the rate 1 bit, the 1 GB.
Doktor, soalan kita keluar ke?
Doctor, it's lagging. I
More
cannot see
letter
the
at one
question.
time, faster the
Doktor kena baca.
nampak kan?
Dah nampak dah.
Time's up.
The
Time's
lag,
up.
Time's up lah.
Okay, tak apalah, ni main-main je. Just play. But before this, in my class, there some prize, you know. But online ni nak ada prize juga ke? Okay. More letter at one time, the faster the processor. This is measured in bits. So the answer is bits. So I hope that the wrong one is based because of the technical problems. Okay. Question. Yes.
Kalau doktor bacakan soalan, lepas tu cakap dengan jawapan, kita boleh kot.
Saya cuba lepas ni. Kau tak nampak lambat loading.
Doktor.
Okay. So I try to read the questions. Okay. Dia masa dia cepat sangat kan? Mungkin lepas ni we make it longer lah. Is the ability of CPU or a single core in a multi-core processor execute multiple processors concurrently? The red one multi-core, the yellow one multi-threading, the blue one processor. Okay. Okay, the ability of CPU or single core in a multi-core processor to execute multiple processes. So because we involve single core or multi-core, single core is the keyword here. So it is about multi-threading. Okay. Next. Okay, Halif now. Halif, Vision, GD, Siddiq. Halif, top 5. Next. 2 more questions and 3 more questions. A core is a single processor. Multiple processor have single processor. Yellow program. Multiple. Okay, good. I think you can hear the questions. Okay, a core is a single processing unit. So multi-core is about multiple processing units. Okay. Vision again, GD, Halif, and Leon. No have name here. Okay, good. Next. Two more questions. More core, better performance. Different core can work on different programs. Grade 1 is false. Grade 1 is okay. 51 ni. Ni tak dengar tak dapat kan 51 ni? I hope so.
Tak dengar, tersekat tadi.
Ya.
Sekat doktor.
Soalan dengan ibu keluar lambat. Doktor cakap pun dengar lambat.
Okay. Tak apa, lain kali kita cuba cara lain pula. Okay.
Saya masih di soalan 5.
Ya?
Doktor, yang ni bukan markah quiz kan?
Oh, tak dengar.
Ni markah quiz ke atau?
Sorry, ulang balik.
Kahoot ni dia diambil kita sebagai markah quiz atau just learning?
Tak ambil. Kalau ambil saya beritahu akan ambil. Tapi nampaknya I think Kahoot maybe not possible to take as official quiz. Maybe we use UKM Folio. Okay, maybe I think maybe next week we done a mock quiz. Mock quiz means that just to test. Is there any problems if we use UKM Folio for our official quiz? Okay, don't worry. This one is not for official one. Okay, definitely not because of the problem. Okay, last question. Good. The top 5 now. Last question. Processor only use simple instructions that can be executed within one clock cycle. Yeah, we have not learned about this one, but it is good for you to find more information about RISC, reduce instruction set computer, and SIS, computer instruction set computer. Okay, so there are some hardware that use RISC, some hardware use SIS. So find out more about that. Before this, it's become homework, but today I just want you to, if you want to know more, you can search about this instruction set. Okay, so okay, questions. Okay, I know there are some problems technical part. We'll maybe try another. Okay, any questions before we end our class today? Any question before we end?
No.
No, bro.
No, doctor.
Okay, so that's all for today's class. Good to see that you give the response here. Okay, if you not give, try to give after this, so that I can see that your involvement in class as well. Okay. Lastly, today we look at computer performance. So next week we go to new topics about OS. We finish about hardware parts. This is all about hardware. Next week we begin the first topic about software, which is we look at operating system. Okay, that's all for today. Thank you very much for coming to our class today. All right, thank you.
Thank you, Doctor.
Thank
you,
you.
Doctor.
Thank you.
Thank you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you, Doctor.
Thank you very much, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Welcome. You still need this one?
Thank you,
Anyone?
Doctor.
Okay, welcome.
Thank you, Doctor.
See you next week, Doctor.
Okay, bye.
Bye, Doctor.